All right, welcome to this video where we're going to talk about balancing chemical equations. So a balanced chemical equation is an equation that describes a chemical reaction and follows the conservation of mass. And so um, so really what this is saying is whatever number of atoms we start with, that's how many we should end with. And so if we're starting with 4 carbons, we should end with 4 carbons. If we're starting with 7 oxygens, we should end with 7 oxygens. And so we're going to go ahead and talk about how we balance it. And it's really, really easy. So if you were provided a word equation, first translate the word equation into a formula equation. So sometimes you'll be given a word equation where it doesn't give you the formula. So the first thing you want to do is just write the formulas out. Then what you want to do is you want to use trial and error to balance the formula using coefficients. And what coefficients are, they are large numbers that you put in front of the formula. For example, let's say we have water, which is H2O. If we put a 2 in front of the water, that 2 is going to multiply all of the number of atoms in the water. So if we have 2 H2O, it means we're going to have 4 hydrogens and 2 oxygens. And we'll go over an example of that. Then what you want to do is you want to balance the different types of atoms one at a time. And so what I just usually do is I just start with the first element that I see, and I balance that. And then you go to the next element, you balance that, and you might have to go back and forth to where you might balance one element and then you go to balance another one, and then it makes the first one unbalanced. So it's really just trial and error. So sometimes you'll balance one, you'll have to go back and rebalance it. And so we'll go over some examples. So first, balance the atoms of elements that are combined and that appear only once on each side of the equation. Then what you want to do is balance polyatomic ions. And so if there's a polyatomic ion, you can treat that as one unit. And so if we have, let's say, nitrate, which is NO3 on one side, and we have it on the other, we can treat the nitrate as one unit. So if we have one NO3 over here, but we have 2 NO3s over here, then we can put a 2 in the front to balance that. And again, we'll go through and we'll talk about how to do that. Generally, you do want to save hydrogens and oxygen atoms for last. There are some situations where this isn't the thing you want to do, but generally, especially for combustions, you want to save the oxygen for last. And really, that's the big one, is a lot of chemical equations, especially combustions, it's best to save the oxygen for last. All right. After you've balanced everything, you kind of want to double check that everything is balanced. So just go back and make sure that you've got the right number of atoms on each side. Now, the coefficients should also represent the smallest possible whole number ratio of reactants and products. And if they don't, just divide them and simplify them down. For example, if our coefficients are 2, 4, 2, well, a 2, 4, 2 can reduce down to 1, 2, 1. And so that's kind of what that means. Also, some common mistakes. So here's some common mistakes when writing balanced chemical equation. If you do not write the correct formula, it'll be impossible for you to correctly balance it. You will not be able to correctly do that. Don't forget Hofbrinkel's. Hofbrinkel's have 2 of those elements when they're alone by themselves, and so that definitely changes the way you balance things. Another common mistake is trying to balance an equation by changing the subscripts. You cannot change the subscripts. The only thing you can do is put large numbers in the front. Now, what I mean by subscripts is, notice how for H2O, that 2 is a subscript. Notice how the H2 on the right, that's the 2 is a subscript as well. And so notice the mistake here. You can't just add or remove subscripts. You cannot change the subscripts. Those, once you come up with those formulas, once you know it's H2O, you cannot change that. So this is incorrect. Don't do it. All right, also incorrectly counting the number of atoms or moles of the element in the compound that contain parentheses. All right, so let's go ahead and practice this. How many magnesiums are there? There's 1 magnesium. How many chlorines are there? Well, the chlorine is within the parentheses. That 2 that's on the outside of the parentheses multiplies everything within the parentheses. So really, in that compound, there's 2 chlorines. Because again, that 2 on the outside of the parentheses multiplies everything within the parentheses. And so how many oxygens are there? There's 6 oxygens, because again, that 2 multiplies everything within. So there's 1 magnesium, there's 2 chlorines, and there's 6 oxygens. Now, if there's a 2 in the front, let's go ahead and count this. So that 2 is a coefficient. Let's go ahead and count this now. Well, how many magnesiums are there? Now there's 2 magnesiums, because that 2 in the front multiplies everything it's in front of. How many chlorines are there? There's 4 chlorines, because there's 1 in the parentheses. The 2 on the outside of the parentheses multiplies that chlorine, and then the 2 in the front multiplies it again. And then we have 12 oxygens, because again, in the parentheses there's 3, the 2 on the outside multiplies to 3, making 6, the 2 in the front multiplies by 2 again, making 12. So there's 12 oxygens. Also, putting coefficients in between elements instead of in front. So notice this mistake here. You cannot put that coefficient in between the elements. You can only put it in front of the compound. Now you can put a 2 in front of the oxygen that's on the product side, because there's only oxygen within that compound. So that element or that oxygen's alone by itself, so you can do that. But when you have something like H2O, you can't put a 2 in front. So that is incorrect. Cannot do it. All right, so we're going to go ahead and go through practice problems. Really, these sort of problems really come down to practicing. And so I'm going to go through a few examples, and it will make a lot more sense when you do that, or when we do that. All right, so go ahead and check out the guide to practice. You guys have a great day.